Dear students, today we are studying about our first important theorem in our maths part 2 textbook. The theorem is on the textbook page number 7, basic proportionality theorem. It's very important. There are some important theorem for the board exams, and this one is very important. Okay, so let us start the theorem. If a line parallel to a side of a triangle intersects the remaining sides in two distinct points, then the line divides the sides in the same proportion. Let us see once again the theorem. Theorem is, if a line parallel to a side of a triangle intersects the remaining sides in two distinct points, then the line divides the sides in the same proportion. So before starting to write given, prove, construction and proof, we have to draw a diagram, means figure, for this theorem. So here let us see in this figure triangle ABC. We can see easily triangle ABC, and here a line parallel to a side of a triangle, means here in this figure line L is parallel to seg BC of a triangle ABC. Okay, and line L also intersect the remaining sides in two distinct points, means here line L intersect side AB in point P, and line seg AC in point Q, means P and Q are two distinct points. Okay, then the line divides the sides, means this line L divides the sides, means side AB and side AC in the same proportion. Okay, so with the help of this figure we have to write given. So here let us see given. In triangle ABC, line L parallel line BC or seg BC, and line L intersects AB and AC in point P and Q respectively. Okay, this is given of the theorem. Now we have to write to prove, means what we have to prove here. To prove, then the line divides the sides in the same proportion. Say in the same proportion means AP upon PB is equal to AQ upon QC. Once again I am telling you, the line divides the sides in the same proportion means AP upon PB is equal to AQ upon QC. Now we have to construct some segment here, two segments PC and BQ. So let us see construction. Draw seg PC and seg BQ. Okay, but here construction will be in dot. Okay, Now proof is the main part of the theorem, means how we have to prove this theorem, the method of proving the theorem. So proof, first we can see two triangles here. First, triangle APQ and triangle PQB. Triangle APQ and triangle PQB. These two triangles, let us see, point Q is common for them, and point A, P, B are linear points. Okay, so these points are collinear. So here their height is equal or same. So triangle APQ and triangle PQB have equal heights. So we are using our second property. Our second property, we know that our second property is the ratio of the areas of two triangles with equal heights is equal to the ratio of their corresponding bases. Okay, so areas proportionate to their bases. So area of triangle APQ upon area of triangle PQB is equal to AP upon PB. AP and PB are their bases, so their areas, the ratio of the areas of these two triangles with equal heights is equal to the ratio of their corresponding bases. Okay, now we have to take second pair of a triangle. First we have taken pair of triangle APQ and triangle PQB. Now triangle APQ and triangle PQC. Let us see, these triangles have also a common point P. They have also equal heights, and seg AQ and seg QC are their bases respectively. So the ratio of these the areas of these two triangles with equal heights is equal to the ratio of their corresponding bases. So here also area of triangle APQ upon area of triangle PQC is equal to their basis, means AQ upon QC. Here number 2, first number is area of triangle APQ upon area of triangle PQB is equal to AP upon PB, number 1, and area of triangle APQ upon area of triangle PQC is equal to AQ upon QC, number 2. The reason is same, areas proportionate to bases. Why? Because they have equal heights. Okay, now here we can see triangle PQB and triangle PQC. Let us see these two triangles. Seg PQ is common base of triangle PQB and triangle PQC. Okay, seg PQ is common base of triangle PQB and triangle PQC. Also sec PQ means line L parallel sec BC. So these two triangles are standing between these two parallel lines, means line L and sec BC. So, or hence, triangle PQB and triangle PQC have equal heights also. So, they have equal bases and equal heights. So, their areas are also equal. So, area of triangle PQB is equal to area of triangle PQC. Why? Because we know our fourth property. What is our fourth property? We have already learnt about it. Areas of two triangles having equal bases and equal heights are equal. What is the property? We are using here areas of two triangles having equal bases and equal heights are equal. So here area of triangle PQB is equal to area of triangle PQC. Here we have given number 3. So now we can see number 1, 2 and 3. One number is area of triangle APQ upon area of triangle PQB is equal to AP upon PB. Then number 2 is area of triangle APQ upon area of triangle PQC is equal to AQ upon QC. And here number 3, area of triangle PQB is equal to area of triangle PQC. Means here we can see number 1, statement number 1 and in statement number 2. The numerator of left hand side is equal, only denominators of left side are different, but these denominators are equal also from the number statement number 3. So from statement 1, 2 and 3, area of triangle APQ upon area of triangle PQB is equal to area of triangle APQ upon area of triangle PQC. Okay, means here the denominators which were different, they are also same because of the statement number 3. Okay, so from 1, 2 and 3, area of triangle APQ upon area of triangle PQB is equal to area of triangle APQ upon area of triangle PQC. Okay, so here we can easily see that the left hand side of statement 1 and left hand side of statement 2 are equal. So we can easily write the right hand sides of statement number 1 is equal to right hand side of statement number 2, means AP upon PP is equal to AQ upon QC. Okay, so here we can see the last step of this theorem, means basic proportionality theorem, is AP upon PB is equal to AQ upon QC. The reason is from statement number 1 and 2. Okay. Now once again I am explaining you. First of all, the theorem: if a line parallel to a side of a triangle intersects the remaining sides in two distinct points, then the line divides the sides in the same proportion. So first of all we have to draw a figure, means triangle ABC, then line L is parallel seg or segment BC, and line L also intersects AB and AC in the point P and Q respectively. Okay, so here we have to write given: in a triangle ABC, line L parallel line or seg BC, and line L intersects AB and AC in point P and Q respectively. This is the given. Now we have to write to prove. Prove means the second half of the theorem, means then the line divides the sides in the same proportion. In the same proportion means AP upon PB is equal to AQ upon QC. Means the line L divides the sides, means AB and AC in the same proportion, means AP upon PB is equal to AQ upon QC. Now construction, you can see in dots. Draws seg PC and seg BQ. Draw seg PC and seg BQ. With the help of this construction, we can see the triangles in this figure. So let us start now. Proof. At first, the pair of triangle APQ and triangle PQB. Let us see here, these two triangles have equal heights. So the ratio of the areas of these two triangles with equal height is equal to the ratio of their corresponding bases. So area of triangle APQ upon area of triangle PQB is equal to AP upon PB. The reason is areas proportionate to bases. Why? Because they have equal heights. Or we can write also as triangles with equal heights. Okay, instead of areas proportionate to bases, we can write triangles with equal height. Okay, and now we have to take second pair of triangle, means triangle APQ and triangle PQC. They have also equal heights, and their bases are AQ and QC. So their areas are also proportionate to their bases. So area of triangle APQ upon area of triangle PQC is equal to AQ upon QC. Statement number 2. Now here we can see seg PQ is common base of these two triangles, means triangle PQB and triangle PQC, and here also seg PQ means line L parallel to seg PC. Hence triangle PQB and triangle PQC have equal heights. And we know very well that areas of two triangles having equal bases and equal heights are equal. so their areas are equal, means area of triangle PQB is equal to area of triangle PQC. Statement number 3. So from statement number 1, 2 and 3 we can write area of triangle APQ upon area of triangle PQB is equal to area of triangle APQ upon area of triangle PQC. Means the left hand side of statement number 1 is equal to the left hand side of statement number 2. The left hand side of number 1 is equal to the left hand side of statement number 2. Okay, so from 1 and 2, here the left hand sides of statement 1 and 2 are equal, so we can write easily that the right hand side of statement number 1 and right hand side of statement number 2 means AP upon PB is equal to AQ upon QC. Okay, so in this way we have studied the important theorem of our maths part 2. The first theorem of our textbook, very important, basic proportionality theorem. Okay, now the converse of basic proportionality theorem. Here is a statement of it. Theorem: if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. What is the statement? Statement of converse of basic proportionality theorem is: if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Means here you can see in this figure on page textbook page number 8, in triangle ABC, line L intersects the side AB and side AC in the points P and Q respectively, and in the same ratio means AP upon PB is equal to AQ upon QC. So here line L parallel seg BC of triangle ABC. Okay, here only the statement of converse of basic proportionality theorem. Students, now we are starting practice set 1.2. But before starting the practice set, I have to tell you something, that because of the corona situation, our education minister reduced our syllabus. So here in practice set 1.2, example number 1, then example number 3, then example number 5, 7, 9 and 10, 11, these examples are reduced from our syllabus. So now we are starting with example number 2. Our second example, let us see in this figure. In triangle PQR, PM is equal to 15. Here PM is equal to 15. Then PQ is equal to 25. PQ is equal to 25. Then PR is equal to 20. PR is equal to 20. And NR is equal to 8. Okay, state whether line NM is parallel to side RQ. Give reason. So here first of all we have to find side MQ and side PN. Means here PR is equal to 20 and NR is equal to 8. So PR minus NR is equal to PN. Then we will get MQ also with the help of PQ and PM. Means MQ is equal to PQ minus PM. Okay, so let us start now. Yeah, PR is equal to 20 and NR is equal to 8. So here PN is equal to PR minus NR. Here the reason is PNR. So PN is equal to PR is 20 minus NR means 8. So PN is equal to 20 minus 8 is 12. Okay, now we have to find MQ. So PM is equal to 15 and PQ is equal to 25. So MQ is equal to PQ minus PM. So MQ is equal to PQ means 25 minus PM. PM is 15. So MQ, here MQ is equal to 25 minus 15 is 10. So here PN is equal to 12 and MQ is equal to 10. Okay, here the reason is PMQ. Now we have to identify the ratio of PN is to NR and PM is to MQ. So first PN upon NR. Now PN upon NR is equal to PN is 12 upon NR is PN is equal to 12 and NR is equal to 8. NR is equal to 8. So here 4 3s are 12 and 4 2s are 8. So Pn upon Nr is equal to 3 upon 2, number 1. And now Pm upon Mq. Pm upon Mq is equal to Pm is equal to 15 upon Mq is equal to 10. Okay, so here 5 3s are 15 and 5 2s are 10. Here number 2. Okay, so now here Pn upon Nr is equal to 3 upon 2 and Pm upon Mq is equal to 3 upon 2. So from 1 and 2 these two ratios are equal. Okay, so here Pn upon Nr is equal to Pm upon Mq. Here reason is from 1 and 2. Okay, means here line NM divides the sides PR and PQ in the same ratio, means Pn upon Nr is equal to Pm upon Mq. So line NM parallel side RQ. So line NM parallel side RQ. Here the reason is converse of basic proportionality theorem. The reason is basic converse of basic proportionality theorem. So in this way we have solved our second example in practice set 1.2 with the help of converse of basic proportionality theorem. Okay, now we have to solve example number 4. Let us see here example number 4. Here the question is measures of some angles in the figure are given, means here measure angle APQ is 60 degree and also measure of angle ABC is equal to 60 degree. Prove that AP upon PB is equal to AQ upon QC. So in the figure angle APQ is equal to angle ABC. Why? Because each angle is equal to 60 degree. It's given to us. So angle APQ congruent angle ABC. Okay, So seg PQ, seg PQ parallel to side BC, sec PQ parallel to side BC. Why? The reason is converse of corresponding angle test. Sorry, converse of corresponding angle test. Okay. This is number one. Then in triangle ABC, sec PQ parallel side BC. Reason is from 1. So AP upon PB is equal to AQ upon QC. Reason is basic proportionality theorem. So let us start now. Here in the adjoining figure, angle APQ is equal to angle ABC is equal to 60 degree. Here reason is given. Okay, so these two angles are congruent to each other. So angle APQ congruent angle ABC. Okay. So here sec PQ is parallel to side BC. Sec PQ parallel side BC. Here number 1. And here reason is converse of corresponding angle test. Converse of corresponding angle test. Okay. Now in triangle ABC, seg PQ parallel side BC. Here reason is from 1. So with the help of basic proportionality theorem, AP upon PB is equal to AQ upon QC. So AP upon PB is equal to AQ upon QC. Here the reason is basic proportionality theorem. Okay, this is the reason. Now here example number 5, then 6, 7 and 8 and 9 are reduced from our syllabus for this year only. So now we are starting our next example number 10. Okay. Here let us see in this figure In this figure, what is given to us in this figure? X is any point. X is any point in the interior of a triangle. Which triangle? Of triangle DEF. X is any point in the interior of triangle DEF. Point X is joint to vertices of triangle. Means here point X is joined to vertex D, vertex E and vertex F. Means here point X is joined to vertices of triangle. Okay. Sec PQ parallel sec DE. Sec PQ parallel sec DE. Sec QR parallel sec EF. Sec QR parallel sec EF. Means here we have given sec PQ parallel sec DE and sec QR parallel sec EF. Now we have to prove that sec PR parallel sec DF. Sec PR parallel sec DF. And here this example is in the form of fill in the blanks. So here fill in the blanks to prove that sec PR parallel sec DF. Okay. So here let us start now. Starting with proof. First of all, we have to see here triangle XDE. Triangle XDE. Can you see that triangle? Triangle XDE. Okay. In this triangle, sec PQ parallel DE. Sec PQ parallel sec or side DE. Here the reason is given. Okay. So in the first line, in triangle XDE, PQ parallel DE. Here reason is given. Now here, so in this triangle XDE, line PQ or sec PQ parallel sec DE, so XP, with the help of basic proportionality theorem, XP upon PD is equal to XQ upon QE. Okay. So here XP upon PD. Yeah, XP upon PD is equal to here dash upon EQ. Means here XQ or QX. Yeah, QX upon EQ. Number 1. Reason is basic proportionality theorem. Okay. Now we have to use basic proportionality theorem in triangle XEF. Can you see the triangle XEF? In this triangle, sec QR parallel sec EF. In a triangle XEF, sec QR parallel sec EF. So here in triangle XCF, QR parallel EF. The reason is given. Okay. So here sec QR parallel sec EF, so XQ upon QE is equal to XR upon RF. So here we can write XR upon RF, XR upon RF is equal to QX upon EQ, QX upon EQ. Okay, here number is 2 and the reason is basic proportionality theorem. Basic proportionality theorem. Basic proportionality theorem. So here from 1 and 2, let us see here the right hand sides of statement 1 and 2 are equal. So the left hand sides of statement 1 and 2 are equal also. So here XP upon PD is equal to XR upon RF. What? XP upon PD is equal to XR upon RF. Here reason is from 1 and 2. So here sec PR in triangle DXF, sec PR parallel sec DF, and the reason is converse of basic proportionality theorem. Okay, so in this way we have solved our 10th example in practice set 1.2. Here also 11th example is reduced from the syllabus for us only for this year. Okay.